Thanks, everybody. Good afternoon. I'm Vito Genovese. When I'm talking about Defense CTF, a lot of you will know me from other scenarios with different names. My Twitter name is Vito LBS, and my email is Vito@legitbs or legitimatebusinesssyndicate.net. So I'm going to talk about what DEF CON and what Capture the Flag are, how we built our team, how we ran the qualification or quals round, and then how we ran the finals. So DEF CON is one of the oldest continuous running hacker conferences and also one of the largest. It's, I think, about 20,000 people last year. It's pretty cheap. There's another one, Black Hat. Earlier in the week, same founder. It's university. Your boss pays for you to go because it's like $2,000. And DEF CON is the frat party you stay the weekend for on your own dime. This is the entrance hallway where everybody funnels through here. When it's time to buy badges, people line up like a day ahead of time because they sell 20,000 badges, all for cash. This is a tamper-resistant contest. Somebody is delaminating a physical Bitcoin to steal the public key or the private key out of the middle of it. Then they're going to laminate it back together. And long story short, don't buy physical Bitcoins for cash. Capture the Flag is the standard computer security game. If you've seen the documentary, or not documentary, but The Social Network, there's 4 guys, trying to break into a server to win an internship at super early Facebook. You have Jeopardy-style Capture the Flag where there's a big grid or big list of problems. You pick one, you get a clue, you solve it, you get an answer, and you turn that answer in for points. On the other side, we have an attack defense Capture the Flag, where each team has servers, and you hack services on the servers, steal secrets every round, submit them for points, and at the same time, you have to patch your services, keep them available so you don't lose points for SLA, and don't lose flags. So how do you compete in Capture the Flag? You build a team, you get super amazing good at assembly, like so good that when you're presented with a .c file, you compile it and then run it through IDA Pro and get an ugly flowchart out of it. You get really good at web attacks like SQL injection, maybe cross-site scripting, session fixation, and get good at crypto too. You compete in a game, you solve problems. The first time you probably won't do very well, but you take all the problems that you didn't solve, write up solutions for them, and next time you'll do better. This is a website, ctftime.org. They have a list of all the Capture the Flag competitions, and it's a wonderful resource. There's another few dozen between now and when we host qualifications again in May. These are 2 sample challenges from last year's game, Hype Man and Worst Medicine. These are web challenges. I think they're both in Sinatra. The best teams solve these in under 30 minutes each. Good luck. And you've been working all weekend on these CTF challenges. A lot of games are 48 hours, and you get weird. This is a Dunkin' Donuts box of Joe, which is actually just a foil bag of Joe inside a box. It's been at room temperature for about 10 hours, and so how do you build a DEF CON CTF team? At the end of 2012, my friend Genovese is saying, "Oh, Dark Tangent, the CTF or the DEF CON founder, is looking for a new team to run Capture the Flag. Want to help us write a proposal?" So there were about 8 of us involved with this proposal. A few software vulnerability experts, a couple good hardware guys, a fantastic network engineer. Like this guy can type routing rules into routers and stuff faster than I can mash my fingers on the keyboard and type literal garbage. I'm a web app generalist. I've done Rails for a long time. I do a lot of NoSQL stuff. I really, really love SQL. I can make websites go on Heroku. First Heroku plug, I have not been paid. So we get a bunch of opinionated smart people who absolutely need to work together on a software project, hardware project with dozens of moving parts on stage, in public, and we don't have any controls of the deadlines. This is a recipe for disaster. What we did find worked was, everybody just does what they can. If you need help, ask for it. If you aren't sure if something is going to work, if you aren't sure if something somebody else is doing is going to work, either keep your mouth shut or demonstrate and build something better. It's better to have something working in the end and have a functioning team than to be the guy who says, I told you so. So, qualifications. We submitted the proposal at the end of February, and by the end of March, we found out we were going to win, which gives us a timeline from end of March to beginning of August to build a qualifications round, run them, and then build finals and run them. So we had about 2 months to put together Quals. Quals is a Jeopardy-style game. There's self-contained questions. Anybody in the world with computer can enter it, and we ran it for 48 hours over a weekend. We did build, this shows 25 problems. We actually built 24. Lots of different categories, web category, I think that's shellcode, that's a different shellcode or binary category, ACM-style programming challenges, and then reverse engineering. A lot of these questions have been solved, that's what the little hearts mean. The one on fire means it's unlocked and hasn't been solved, and the dark red ones, and that's animated GIF fire, by the way, and the dark red ones have not been unlocked and nobody knows what they are. You can see PPP, the Plaid Parliament of Pwning, they're at the top of the list. They stayed at the top of the list through Quals, through finals, and they were on CNBC as well. So the Quals Scoreboard, I know Rails. I built it in Rails. I used Unicorn, Heroku Gigabyte dynos, the cheapest good Postgres you can get. This is the stack that I deploy in 2008, and it still holds up really well. We didn't bother with Redis or Memcache because I read some article that I've forgotten the link to that says, oh yeah, sometimes they're just slower than Postgres because Postgres is really fast. We didn't have any server to client push. We just pulled a lot. Push is easy. There's lots of great add-ons on Heroku, but writing a JSON API and calling it with JavaScript is easy. We did use New Relic the whole time, and we had a great spike at the beginning of the game in requests per minute, and it stayed steady at about 1,000 through the whole game. We did get complaints that the game started on time and didn't go down. That was kind of cool. We used a lot of database. Most of the Postgres requests came in under 5 milliseconds, fast enough. And with our 6 1 gigabyte dynos, we launched the game, and we kept the time per request at about 50 milliseconds. Then about a day later, I'm like, well, we could save some money by getting rid of some of these dynos. But while we would get rid of dynos, a bunch of requests would get in the queue, and it'd be really, really slow. And to make a long story short, we didn't save enough money because it didn't matter, and we spent more on whiskey than on computers anyways. So beside the scoreboard, we had the 24 challenges that actually worked. Sinatra, lots of x86, Golang, which is a kind of x86, I guess, ARM, PHP, and Python. The Sinatra stuff, we used Heroku. It ruled. I pushed it up, and then they're still up. Everything else, except for the ARM challenges, we used EC2. We started with micro and found out, do not use micro instances in production. They're terrible. You get bad neighbors, and now your app is slow. Or you get DDoSed, and now your app is slow. The ARM challenges, we had 3 Raspberry Pi units in a bucket at a university data center. These are Model B units, so they have a built-in USB hub and Ethernet already, and they're amazing. They just keep on trucking. So we did have problems. I had to sleep, and then we had to edit a question and update some files on S3, and nobody else knew the scoreboard because we hadn't controlled our bus number. So the other guys had to go make a new S3 bucket on a new account, upload files, and just spam the hell out of Twitter and IRC, saying, oh, the files are actually here, disregard the question, it's lies. Some challenges weren't ready until halfway through the game. So Worst Medicine, one of mine, I got the idea for it in a dream while I was sleeping through part of the game. Implemented it, it's a cool bug, but then there's a considerably less cool bug that it's also vulnerable to. And there were 2 possible solutions, and basically you had 2 choices of which way to go, and they both worked, which made it about half as hard as it should have been. Another problem, we just never got it built out and satisfactory, and we replaced that 5-level super hard question with hack the planet, which is a CTF tradition. My favorite bug was Roman Soft of the team int3pids. One of his teammates clicked submit on a challenge twice and got points for it twice because somebody forgot a Postgres index, and I added the index, didn't have to redeploy the app, and it was gravy. So having IRC and Twitter to communicate with competitors constantly, invaluable. The problem is we didn't have a reset password flow, and I was mostly using IRC and Twitter to coordinate resetting people's passwords by hand. Don't forget having public views. So when we launched the game, you had to be logged in and on the scoreboard to see who was winning. And lots of people wanted to send links to their parents or kids or whatever and say, oh, look how great I'm doing. And what we did halfway through the game was we made another Heroku app, wired it to the same database, and showed public scores there. We didn't control bus numbers very well. I was the one who knew how the scoreboard worked. Somebody else knew how lots of challenges worked. Somebody else knew how to use EC2. I don't. So qualifications was pretty easy. We could use cloud services. It was all online. We could sleep in our own beds at home. Finals is a different story. Finals is huge. My DEF CON history is in college. I took a computer security class, and a professor was just super hype about it, and I can show the video later of him on Jeopardy getting hype about it. But like you walk into DEF CON, and the CTF room is like right in the middle. You walk through it on the way to talks. They're always showing like distraction videos. There's tons of dudes like, you know, knee deep in notebook computers, or like one team brings this like giant cube of servers. And there's just intense, there's a lot of emotion in the room. And then there's like, I was told they were like the most elite dudes in the world are on the pedestal in the middle of the room running the contest. And right about like the day before DEF CON, where I'm driving a rented Prius from the banner place back to the casino with banners that I designed, it hits you like it's happening. So this is what the finals room looks like. This is PPP, and there's a link to their CNBC story that you can get later. They have their power book that shows messages and is really bright, and I made them turn it off. You have power when you're on a pedestal. But when we got there, the room was just empty. This is our pedestal in the middle. We eventually filled it with like 24 or more, like 36 computers up there. And this is half of the room looking out from there. It's lots of people. We kept the lights down. We tried to keep it chill so that like people could concentrate. It was just an amazing time. And having 20 teams, 20 servers, all on one network is completely different from hosting anything online. We have an attack defense style game where teams get SSH credentials. They connect to their servers, they can start reading these binaries, and they find out, this is ARM. We all prepared for x86. And then, this is Linux. We kind of prepared for OpenBSD. And they have to find out that they have the wrong version of IDA and not the expensive version. But they do eventually get into these services, start disassembling them. A few teams ran out and bought Chromebooks, the cheap ARM ones. Patch your vulnerabilities and attack everybody else's servers. We started the game with 50,000 flags, and we had rounds that lasted 5 minutes. So at the beginning of a round, we would deposit brand new tokens on every team's server for every service. And then at some point within that 5-minute interval, we'd check to make sure everybody's services were still up and running. What teams would then do is they'd try and hack into other teams, steal the tokens while they were still valid, and return them to us. If they took their servers down, they lost a bunch of points. If they got any tokens at all stolen, they lost a bunch of points. So the final scoreboard, I was remembering the first time we went there, they had a huge rack of servers running the game. I had a Mac Mini, the 16 gig one, dual core or quad core, no optical drive, and I put Linux on it and ran Unicorn and Apache Passenger and Postgres, and it just spent all its time sitting idle, like 12 gigs of RAM just free. Fantastic. We used client certs for authentication because it adds a lot of security. Instead of having to worry about password resets, never again, we could just get to the conference area at 8 a.m. on a Friday in Vegas and burn 20 CDs. It's pretty miserable, but it works. Yeah, client certs, no password resets, all the network traffic's encrypted, burning 20 CDs, I could take it or leave it. We used Kibana and Elasticsearch for processing logs. And this was really nice because teams would come up and they're like, well, we tried to score this flag, but it says it was too old, just like that. And I could punch in and say, oh, is it the flag that ended with RWV4? And they're like, yes, it's too old. Yes, it is too old. Don't try and score it anymore. But logging everything's super valuable. Actually checking the uptimes, we had a console Ruby script that stored all its state in the current wall clock time and Postgres. If we had to patch it, I'd Control-C it, make sure it wasn't doing anything valuable, and restart it. So 2 weeks before the game, oh, I'm just going to call a bunch of shell scripts. Name your shell script this, and it takes these arguments. 3 hours into the game, some teams had broken their services, and they just never respond. And I learned about the alarm system call and how you can call that to make your script magically kill itself after 20 seconds. But it was still too slow because we're running about 100 of these scripts every 5 minutes. And we eventually moved them to parallel the night after during our planned downtime. One team started puking binary out, and we quit saving standard out into the database instead of fixing it correctly because we just wanted it fixed. The big problem, or one of the big problems, was teams could score on themselves. So your goal is to keep other teams from getting your tokens and submitting them for points. If 19 teams scored a service, there would be 19 flags distributed 19 ways. If one team scored a service, it would be 19 flags distributed one way. We had 20 teams. So if one team hacked it and the other team just submitted their own flag, the other team would only get 9 flags, and they'd keep 9 flags. This was unintentional, but I didn't put the right constraints in the database against it. We didn't find out about it because the Men in Black Hats team waited until after the contest was over to tell us the problem. The other half is, so 19 flags, split one way or split 19 ways. That works really well mathematically. If you're splitting it 2 ways or 4 ways or 12 ways, now there's remainders. What we were supposed to do is save the remainders and then at the end of the round give them to all the teams that scored any points at all. What we did instead was we just sort of kept them. And if we were on the scoreboard at the end of the game, we would have been in 3rd or 4th place, even though we weren't playing. So there were a lot of issues that I got okay at Kibana searches, pretty good at AREL, and decent at SQL for debugging problems, answering teams' questions, etc. This is still a lot of work, and I had a lot of just text edit windows with SQL in them. Next year, or this year rather, we're going to actually have admin screens where we can run queries without having to type queries. For actually submitting flags and scoring points, we gave them curl and a JSON API that would tell them what each flag was. This didn't get described really well. And there are a few really, really funny cases where teams would have flags that have a double quote, semicolon, RM minus RF /. And one team's server they were using for automating scoring got wiped out that way. And it's their fault, not mine. But so that was a decent level of API documentation, but we could really do a lot better. Life is really, really easy when you only have 160 users and they're all in the same room as you. If somebody's bothering you, or not if you're, well, if somebody's coming up with a question and you're like, F off, I'm busy, they can cope with that, and I can cope with that. We did have some network issues and got them solved. So these are what the team servers were. These are Odroid U2 units. They're a 2-inch cube, mostly heatsink, but a dual-core ARM box. These were fantastic. We were really, really worried about having hardware problems. So there's 22 machines in this 2U container, 20 for the teams, one as a canary to make sure our scoring scripts are running correctly, and then one as a backup. So for the scoring scripts, instead of checking uptime on 20 machines, we check it on 21. And if the 21st machine that teams couldn't hack or even see on the network was down, nobody lost any uptime points because it was obviously out of team control. That super well. Individual services, they all ran as dedicated users. So like Avoir was on the Avoir user, AppMail was on AppMail. Teams got their own account. They could sudo to service accounts, but they couldn't sudo to root, which saved us a lot of problem and made a lot of really, really clever defenses like, oh, we're just going to patch the network driver and not allow any tokens to leave. Or we're going to patch the file read system call and not allow the token file to be opened at all. Not a problem. Our network was complicated. I don't know networks very well, but there's like VLANs and routing. And the big headlining features for me were all the teams had internet access instead of out of a wire at their table instead of Wi-Fi on the sketchiest Wi-Fi network in the world. And finally, scheduled downtime. I love scheduled downtime. We'd play the final countdown, kick everybody out, and we'd have 14 hours to go eat, sleep, patch software, all the things you love to do on an evening in Vegas. So that's the 4 big topics I wanted to hit. Lessons. Stuff will break. It's just, it's physical, it's technology, it'll break. But you have to own all your problems. So when we didn't redistribute flags and I didn't figure it out until I was on the plane back home, I had to own that because we were going to release the data and everybody was going to find it out anyways. So it was a little bit embarrassing, first telling the team and then telling the world that we screwed up. But we did screw up. No matter how we were going to phrase it, it's a mistake we made. By talking about it, I remember, and I'm not going to make that same mistake next year. And hopefully nobody else will either. We did have a lot of features that we wanted to build, that we wanted in the game, but I'd just say, oh, we'll worry about that in 2014. We want to get anything at all released. That's a circular answer, fighting scope creep by fighting scope creep. But it works. And finally, we did it. Your customers, your friends, nobody's going to see your daydreams, your whiteboard doodles. You actually have to build software and write code and run stuff and get an experience and get a feeling for how it works. If we hadn't just gone out and written a proposal and said, we'll wait another 4 years, I wouldn't be here. And we wouldn't have all these great lessons, valuable stories, et cetera, to talk about. So that's it. Here's my contact information again. Our homepage is legitbs.net. And that bit.ly link at the bottom is where we have all of the other links I've shown. Any questions?